Hello and welcome to this .NET Nugget session. It's one in a series of short sessions where we spend 10 minutes or so looking at how we can do things with Visual Studio and the .NET framework. My name's Mike Talty and I work in the Developer and Platform group at Microsoft in the UK. And in this particular session we're going to look at a component of WinFX, the Windows Communication Foundation, a technology for building distributed applications. And in this session we're going to zoom in a little bit and look at the serialization of data as it flows from a service to a client and vice versa. Okay, here we are with Visual Studio 2005, and I'm using the September technical preview of WinFX. What I've done here is just built a very simple console application that serves as a service and another one that serves as a client. And the service itself, it's very simple. We have a contract, it's called iPersonLookup. And we've attributed it to say it's a service contract, has an operation on it, again we've attributed that, and this operation takes an arbitrary integer and returns an instance of this type person. Now person is just a very simple type. Person has a first name, a last name and an age property, all backed by private member variables, and that's all that happens with person. We have a very simple implementation of the service. When somebody comes and asks us to get a particular person, we create a new instance of that type, we set some properties, and we always return the same thing. Finally, just like we had in our Hello World sample, we've got an instance of service host, which is being used to provide an implementation of person service, and we're just opening that thing up, and we're using, again, a very simple binding. So here's our service, and we're just using HTTP with the basic HTTP binding in order to make that thing available. Once again, if we look at the client, all we've done with the client is build a console application. We've added a web reference to our web service, and then in the client code all we've got is an instantiation of a proxy, and then we call that getPerson method on the proxy, and we write out the details of the person that's actually returned back to us. Okay. When we look at the interface that we defined for our service, we have this type person, and as it stands the code wouldn't work because we haven't specified to the WCF how it's supposed to return an instance of this thing across the network to the caller, across the service boundary to the caller. Now there's a number of different ways that we can actually go about the serialization of a type like this in a WCF contract. The first way that we can do it is by using the serializable attribute that has existed in .NET Framework since 1.0, and this was mostly associated with .NET remoting in earlier versions of the framework. And in many ways for the WCF this is somewhat of a legacy mechanism for doing serialization. So what it means is that any type in the framework which is already marked as serializable can be serialized by a WCF interface, and that would include things like hash table. So the way that this works is that both your private and your public state will be serialized. You can stop things being serialized through use of the non-serialized attribute. And you can also, if you want, to take full control over the serialization by implementing iSerializable and reading and writing yourself to and from storage. Things such as have methods in the class that are called at various stages within the serialization lifecycle. An example we can write a method such as this one, and we can just apply the onSerialized attribute to it, and that method will be called after an instance of this type has been serialized, and we'll put a breakpoint in there just to make sure this happens. So with that in place we can build and run this service, and if we just run the client and the service you can see that we get our breakpoint and that ultimately the client gets his person back from the service. So this form of serialization is really here for historical reasons as opposed to modern reasons. There are two other forms of serialization that you're much more likely to use with a WCF service. Now, the first one of those would be the technology that we've used with ASP.NET as MX web services in the past, which is XML serialization. So we can always go and take one of these types and we can attribute it using the standard XML serialization attributes that we've had in the past. And we can specify names and namespaces and so on. And take control over how things are serialized. Now, XML serialization only deals with public types, and also it only serializes the public parts of those public types. And there's many things that it won't do, such as follow through object graphs and so on. It's very much an XML-centric view of serialization. There's one more thing we have to do if we want to use XML serialization for this particular contract. We have to go and attribute the contract to say that we're using the XML serializer. Now with that in place, we can go and build our service using XML serialization. We can go and update the web reference on the client side. So let's just update that web reference. Rereading the WSDL document from the service. And if we rebuild the client at this point, I would expect some failures because we changed what the schema looks like in the WSDL, so we just have to tweak these properties very slightly, and you can see that the serialization choices are already creeping through to the proxy on the client side here. And if we were to shut the service down, shut down the client, and look at the messages that were exchanged, just with some tracing, we'd see that the messages that went across the wire look exactly as we specified them in the sense of having a first and a last and an age attribute through XML serialization. XML serialization, something that's already present in .NET Framework 1.0, enhanced in .NET Framework 2.0 so that you can do things such as implement the XML serializable interface and control your XML serialization explicitly and do all the work you want in there yourself, should you want to, and not go down the route of attribute-based serialization control. Now in the WCF, neither one of these two models is the standard serialization model for WCF services. We've really shown them here just to show that they're still there and that you can use them if you want to. For the WCF, the standard way of serializing data between services is to define a data contract. So the way that that works is that we attribute up this class to say that it is part of a data contract, and you can see that we can control things like the name and the namespace here. Now the way that data contract works is that by default nothing will be serialized, but it can serialize both private and public state. And the way that we do that is by applying this data member attribute to the things that you want serialized and deserialized. If you apply this to a property like the one we've got here, then as you would expect, the get and set operators will be used during deserialization and serialization. Through this attribute, we can also control things like whether deserialization should fail if this member wasn't found in the serialization stream, i.e. is this property absolutely required in order to produce a valid instance of the object. We can control the name, and we can also control the order in which things are serialized. So perhaps it's important to us that last name is always deserialized after first name or something like that. So if we just attribute up the rest of our members with data member here, then we should be good to go and rebuild our service. We'll just run the service so that we can update our proxy. This is a consequence of using console applications. We'll stop our service. Make sure that we can build the client. Just change things that have differed since the last time and the last type of serialization we used. So you can see that the proxy again has been changed. And we'll just run that to make sure that it still does what we expect it to do. So our service comes up. If we start our client, it calls across to the service and works the way that we expect. And if we let those two things go down, we can go and look at our traces again. And see the messages that have just been passed back from the service. So once again, we've got a bunch of serialization stuff. So we've seen that for the WCF, it's possible to use binary serialization interfaces as we had in .NET 1.0 with just the serializable attribute. We've seen that we can use XML serialization just as we had in .NET 1.0 for ASMX web services. And we know now that the default way of serializing things for the WCF is through data contracts, and we have to attribute all the things we want to get serialized with this data member attribute. We'll come back in a subsequent nugget and talk about some more details on this data contract serialization, but we've seen the choices that we've got around serializing things for the WCF. Let's just summarize what we've seen in this short session. We've seen that with the WCF, when we define a contract that separates two services, types that are members on the operations of that contract are serialized as they pass between the services, across the boundaries between the services. And we've seen that there's a number of different ways we can do that serialization. Mostly for legacy reasons, we can have .NET serializable types, such as hash table that existed in the .NET Framework 1.0. We can also use XML serialization, as in system.xml.serialization, which exists again since .NET Framework 1.0 and has formed the basis of type serialization for ASP.NET ASMX web services in the past. And we've also seen that we've got a new serialization technology, again living within system.runtime.serialization, which is the data contract. And we've had a look at what that gives us and what we benefit by using that mechanism for serializing our types. Okay, where would you go if you wanted to get some more information on the Windows Communication Foundation? Well, the best place to start is up at msdn.microsoft.com/winfx. And if you want to find some more information about the protocols, the web service open standard protocols that the Communication Foundation is capable of using, a good place to go for that would be msdn.microsoft.com/webservices. And that particular link we have on the slide here, /understanding, there's a great document there that specifies how all these things fit together to make a distribution platform as opposed to just a random set of specifications. And finally, if you want to follow up with anything you saw in this little session, feel free to drop me an email. My address is there on the screen. It's just mtolty@microsoft.com. Other than that, thanks